Okay, now we're still working with research, and now we're going to look at generate test data. This is a most important part of any research work. Once you've found something interesting that you think is interesting in your data, you need to see if it is dependent or connected to a feature of your data, or whether it's just a randomly natural occurring pattern. In other words, I'll do something really silly now. You have a group of military people who are all born in the 20th century, and you suddenly discover that they have a tendency to have Pluto in Leo, for example. And if you look at that, you think, wow, isn't that interesting? But if you then search the ephemeris, you'd realize that anybody born, say, in that group of years, say the war years and into the 50s, anybody born in that time would have their Pluto and Leo. And so therefore your result was not linked. You can't say that Pluto and Leo is military people because it's there for all people. That's a really obvious and almost silly example. But sometimes it's good to think of the really obvious thing, because then you understand what's going on. So, for example, you could be looking at your military people born during the war years and into the 1950s, and you might find, for example, that your military people were all born with their Jupiter in a certain sign. And then you go and you check a normal ephemeris, or you create control groups of people who aren't military people, and you look at the same span of time, and you look at their Jupiters, and you find the Jupiters are all over the place. Then, just possibly then the Jupiter in a certain sign may be related to the military fact, which is the common theme in your data. Possibly. You'd still have to do a lot more work, but that's the type of thinking. So, to help you sort out what are the natural patterns and what is worth pursuing further, Jigsaw comes with this generate test data option, which is really important. To open it, you simply click on it. You can of course open it up here, generate test data, or open it here. We've already got the actors open, so if you had no files open, this would be grayed out. So if you're looking at it and you can't select it because it's grayed out, then go up and open a file and select anything you want, open it, and then you'll find that these will be darkened. Okay, so let's click generate test data. Alright, this is now reminding you that you've got the actors as a base plate here. The reason it's doing that is that there are two distinct ways you can generate test data. You can generate it using a basic project you've already got loaded, using a project as a base. For example, here, if with the actors, if we use the current project as a base, then the total number of records that is going to be contained in our control group will be 399, because that's the total number of records that are contained in the actors. We could then, using this base, we get options down here about replication. We could replicate the years. So in other words, we could build randomly another 399 records which would match the years of birth of our actors. So in other words, if there were 10 actors born in 1920, then our control group would have 10 actors born in 1920, and so on. We can also extend this and say days and months. So that would actually reproduce all the birthdays of the actors, but of course not the location or the time. We could actually replicate the times of the day, so that would reproduce a whole new control group for our actors, based on our actors, which would be the same year, the same days, the same months, and the same time of the day, but different long and lats. Now that's something you may want to do if you were looking at the rising signs or particular relationships the planet has to the cross of matter, because the only thing then that would change in this group would be the angles. The ascendant and the MC would move around a little bit because of the variation of the longitude and the latitude. If we clicked that, then we would actually get a control group containing 399 charts, which would be exactly the same, because we're reproducing years, days, months, times, and the location. So that would be a total duplication. You can select or unselect any of these. You can change the years around. You could actually keep everything the same but change the days, or you could actually keep everything the same but change the times, just to see if there was a tendency in terms of the geometry of the solar system and the way the Earth rotates, if there's a tendency for planets to be in certain arcs at certain latitudes longer. For example, in the summer months, the sun is well above the horizon line, particularly at high latitudes, which would be different to the same date, but the opposite hemisphere, the sun would have less amount of time above the horizon line. So you can fiddle with this and create your data or your control group based on your current project, and you can tune it quite precisely, really depending on what you're looking at. The other thing we can do if we're working with a particular selection of data is that we can apply a time shift, a uniform time shift. One way of creating control groups is to, you notice this turns everything on, is to reproduce the entire control database as exactly, so it duplicates it, except apply a shift. Move everybody forward 1 day, for example, or 1 hour, or 1 minute, or 1 second. And of course, we could say, let's move them forward 2.5 hours, for example, or days, etc. So depending on what you want to do, depending on what you're researching, you can create a control group which is based on your selection of data, but just applies a uniform shift to it. And we can now also go back a day, minus -1, minus whatever number you want to put in there. Using this option will depend on the research work you're doing. But if you, for example, have several thousand charts in your system and you find something, depending on what you find, you can create a control group which is based on that project. You can change certain things about it, so you really are testing something unique. You're hoping that a unique thing in your data will maintain itself and will not be represented in the control group that you create. Okay, so this is an important part, and it would be, for those of you who've been doing research, you would be familiar with applying uniform time shifts and building such a control group. Another really important feature of Jigsaw is the ability to create independent control groups. So if we click Generate Independent Data, then we no longer can replicate the data because we're doing an independent set, but now we have to arrange the sequencing of that, the date intervals in this part of the screen here. The most useful, I think anyway, the most useful use of the independent data control groups is the ability to create ephemeris. Now, if you are finding that there is a tendency for Mars to be in Virgo in your database, for example, then you may want to generate ephemeris for a particular period of time which is matching the same time, and then run the same experiments on that to see if Mars has a tendency to be in Virgo quite naturally. And if it is, then you know that that is not a feature of your database, it is simply a feature of the way that Mars moves around the solar system. Some of these are fairly obvious. Indeed, Mars does prefer to spend more time in Virgo, Leo, etc. Some of these are fairly obvious and we know them, but some of them are extremely subtle and we don't know them. And only by generating an ephemeris and running our experiment in the ephemerides can we actually see if we've got something that's interesting or if we've got something which is simply a natural occurring pattern. So let's generate an ephemeris for the 20th century. Let's just look at that. We're going to generate independent data. Now, we're going to do an ephemeris for 100 years. If we actually asked for 100 records regularly placed between the 1st of January 1900 and the 31st of December 1999, I've entered dates in the European English or Australian way. If you are looking at this and you're in the United States, you can of course change in your preferences how you enter dates into Jigsaw. If we set it up this way, then we're going to generate 100 readings between this 100 years. So therefore, obviously we're going to get, and if we do it regular, we are going to get Jigsaw to calculate one chart per year, one set of planetary positions per year. And as an ephemeris, that's really a bit useless. We don't really want that, but that's what we'd be asking it. So what we want to do is we want to create an ephemeris with far more charts in it, with far more positions in it. And as astrologers, we're used to daily ephemeris. So let's create a daily ephemeris for these 100 years. There are 365 days in a year. If we wanted to do it for 10 years, we just add a naught, which would be 3,650. If we wanted to do it for 100 years, we add another naught. So now we've got 36,500 charts. If you wanted to do it for 1,000 years, and Jigsaw could, you simply add another naught, which would be 365,000 entries in your database. A little bit excessive. Let's just work with the 100 years. So we've set this up to be here with a day for a chart being calculated, or planetary positions being calculated for every single day, right, regularly placed between 1900 and 1999, and so therefore we're going to get a chart per day. If we wanted to also measure the angles for this ephemeris, we're not going to, but if we wanted to measure the angles, we could put a range of latitudes and longitudes in here. This defaults to the whole world, but if we were looking at all our births and they were in London, for example, and we had 100 years of births in London all showing a particular feature, we might want to generate an ephemeris for a latitude range of London. We'd say 50 north to 52 north, just to have a bit of range, and then a longitude range of naught through to naught west 15, for example. And that would then calculate our 36,000 charts for the whole century using a latitude and longitude of London, which then we could actually look at ascendants, MCs, etc., etc. But we're not actually going to explore that at the moment, but that is how you would do it. We'll leave it there because we're not going to look at that, but we'll let it sit there. Okay, now all we have to do is click OK. And the next thing that Jigsaw asks us to do is to name our group. So let's call it something really simple, 20th century. Because what I do is I have these ephemerides constructed for all the centuries, right through from about 0 AD right through to now, and even some 21st, 22nd, 23rd, 24th. I have created all of the ephemeris over many thousands of years, so I can dip in and out. I've even created some ephemeris for 1,000 years, looking at one chart per week, so that you can do many things with this. So we'll save it. And Jigsaw is now creating it, and it's created the file, and it's loaded it up automatically, and it's telling you that it's so many different regular events. Before we do anything with that, let's just go back to the generate test data. I could have set this all up and done random dates, so I could create the same span of time through to the 31st of December 1999, and I could actually ask for it to be random dates. Now that would not be an ephemeris. That could have 10 charts on one day, and then it could have a 50-year span with no charts at all. It's totally random. Obviously, there are some situations where you want to generate just random events. For example, if you've got a group of several thousand people born in a couple of year range, and they're all born at a certain latitude, and they all have a particular feature, they all have a particular illness, or they all have blue eyes or something, and you've actually noticed that they all tend to have Mars in a certain position or in a certain orientation to the ascendant, you could create an independent data set, randomly orientated, to cover the same span of years of your data group, You could do the same number here, keep it random, and just generate it. And then, in a sense, you're going out and you're getting another 2,000 people randomly from the population and looking at their charts to see if their chart has the same thing. So if in your mind you need to go out and collect a whole lot of random people and their charts born in the same area, then you can actually do it. You don't have to go out and do the footwork. You can actually create it here on the screen with Jigsaw. So that would be the random selection. The regular really is for generating ephemeridese. The random is for creating a random collection of birth charts at the particular location you want, for the range you want, and the number that you want. So that's another way of doing it. Okay, so what we have is we have loaded up our 20th century ephemeris. And we can now do research work on that to see if a particular feature we found in one data is actually also in another. So here's our tabulate and search screen. We're going to use this in the criteria search as well, but at the moment let's just play with this. And I could select all the planets. We can just do something really simple here. We can look at the zodiacal position of the planets. Now when I click start here, Jigsaw is going to then calculate all of those 36,500 charts, and here it's doing it. Now this computer is about 5 years old, so it's probably a little bit slow. Depending on the speed of your computer will greatly affect how fast or slow this will do it. This will take us a couple of minutes or so, so we're going to pause here and then we will step in once Jigsaw has completed this search. Yeah, and Jigsaw has nearly finished calculating the 36,500 charts, and once it's finished calculating, it will actually go into the question I've asked it to do, which is actually analyse the planets through the zodiac signs. So here we go now. Reading the records, bang, it's done it. This is defaulted to a polar graph. Let's just play with this for a second. We're now looking at the position of the moon taken every single day for the 20th century, the whole of the 20th century, and we're seeing that its tendency to be in a certain sign is reasonably consistent. So if we just click on this, click on the sun, and then what I'm going to do now is I'm going to use the arrow keys on my keyboard like we have done before, and I showed you in the tabulate and graph tutorial. I'm just going to scroll through the planets. So here's the sun, and you can see that the sun has a tendency to spend more time in Gemini and Cancer in Leo and less time in Capricorn, Sag and Scorpio, and indeed for any and Aquarius. Indeed, for any of you who work with the secondary progressed sun, you would be well aware that the sun speeds up and slows down depending on where it is in its path through the ecliptic. Or rather, I should say, the sun is stationary. It depends on where the Earth is as we travel around the sun. Alright, here's Mercury showing a similar or a bias for Capricorn, Sag and Scorpio. If you take thousands and thousands of people born, then you're going to get a natural tendency for Mercury to be in Scorpio, Sag and Capricorn, and a tendency for them not to have Mercury in Gemini and Taurus and Cancer. So if you'd found that in your group, then by looking at this control group you think, oh no, that's a natural occurring cycle. Here's Venus. We know that Venus does her lovely 5-pointed star. Here are the 5 points in this century, here in Aquarius, here in Aries, here in Cancer, in Virgo and in Scorpio. Here's Mars. Remember what I told you, that Mars has this tendency to spend more time in these signs here rather than in this group over here. So once again, if you were working with 10,000 people who'd joined the army and you suddenly found that they had a tendency to have Mars in these signs, you think, wow, that's interesting. But then when you actually look at a standard slab of ephemeris, you actually see that Mars has a perfectly natural tendency to spend longer in that sign, in those signs, than in the other signs. Down through Jupiter. Interesting, Jupiter likes being in Sag. Hey, rules it, so that's nice. Saturn likes being in Saturn and Aquarius, which is interesting, isn't it? Because they're the signs that Saturn rules. But you can see the imbalance there. And over a 100-year period, that's a fairly good slice. But once again, with Saturn having a 30-year cycle, 29.5-year cycle, you'd probably want to, before you made any big conclusions about that, you'd probably want to take a 500-year ephemeris for Saturn to get a smoother curve of what's going on with its movement. Uranus, we're getting a biased here. Neptune, of course, a real biased, and what we're really seeing is that in this century, Neptune hasn't been in Aries, and that's hardly a significant result. It's simply saying that's the way it is. And of course a similar situation with Pluto. We can look at the mean node. The mean node has an 18-year cycle, so we can see there's a tendency for that in this century to be in the Leo, Virgo, Libra, Scorpio side of the chart. So planets have the orbits are elliptical, remember. Orbits are elliptical, which means that they'll be slow in some signs and fast in others. So be aware of that. And the node, which is a relationship between the Moon's orbit and the Earth, is reflecting those elliptical light orbits also. Okay, so this is a fairly simple question to ask of our 100-year piece of ephemeris. And later on in the criteria search, we will ask more questions of that. But just coming back and summarising this, first of all, just to remember, you've got two ways of doing it, either basing your control group on a data group or basing it as an independent set of data. If you go for basing it on a control group, a group you've got, then you need to make sure that you've got the appropriate group loaded up here. I've got the ephemeris, so it would be a little bit ridiculous to base a current project on that ephemeris. I'd want to go back and open up my actors or whatever group I was working with. That's your first two decisions. Once you've made that decision, if it's generate independent data, all of the replication and time shift options are removed from your consideration, but you actually have to fill in regular or random start and end date and the range of latitude and longitude you want the charts constructed for. If you do go for based on current project, then you've got these options here, and whether you are reproducing years, times, etc. So you've got different ways of building control groups, and this covers most of the standard options for most control groups, particularly when you add the time shift into it. So what I recommend that you do now that you've got Jigsaw on your computer is just use it as practice as well, but actually just generate a series of ephemerides. So we've just generated the 20th century. We could say the 1st of the 1st, the year 2000, to the 31st of the 12th, 2099, and this would be the 21st century. Make sure it's selected to regular. 36,500. Click that. Call it the 21st century. So save, and there you've done it. And then you can go to generate test data. You could keep all of this the same, and you could say start date the 1st of the 1st 1800 to the 31st of the 12th 1899. Say OK, making sure this is regular. Say OK, and we'll call this the 19th century, and say save. So it's a worthwhile exercise just to actually get your Jigsaw set up and create all the ephemeris over several thousand years, all different sorts of ephemeris. Make sure you label them really clearly so that when you actually go to do research work on them to see what's going on, you know exactly what you're looking at. So that's a tip, a good tip. Play with this. Generate different control groups, have a fiddle. Once again, you can't hurt anything, but this is a incredibly important part of the research module of Jigsaw. It's all very well to first of all find something interesting in your data, but if you cannot test it against ephemeris or generated control groups, then you actually don't know what you've got. So it's imperative that you test all your results against some form of control groups. All right. What we're going to go on to now is these two options here, criteria search and filter data records. And that'll be the next lot of tutorials, but this is a most important part, criteria search. And it is in contrast to the tabulate and graph screen. So that's what we're going to go on to. That's what I recommend that you do as your next tute. So take a break and then join me for the criteria search tutorial.